Well, hello everyone, and boy, I love the smell of trouble tickets in the morning. Let's go ahead and take a look at this trouble ticket. And for those of you that are watching on YouTube, you'll find a URL in the description field that will lead you to a trouble ticket for you to go ahead and examine. So you might want to pause the video right now, go to that URL, and check out the particular trouble ticket that we're going to solve. Well, folks, using our quick fire strategy, we know the first thing that we're going to do is we're going to make sure the ticket actually exists. So I can say, for instance, show NTP status, and we see, our clock is indeed not synchronized, and we have a stratum of 16 unreachable. We have no reference clock. NTP is not working as the particular ticket would indicate. Okay, so we verified the problem actually exists. Now we are, if we do a show run and include NTP, we are attempting to get time, sure enough, from the loopback 0 of R9, 192.199. One of the things that many of you like to do, we've seen in classes, is do show IP route right away here and see if R1 has the ability to get to that particular address. Sure enough, R1 just has connected entries in the routing table. Now, if we look at our overall topology, we see R1 exists in an EIGRP area. Interesting. So now I'll jump to show IP EIGRP neighbors. And yes, we do have a neighborship. So real quickly, we just verified several lower layers of the LSI model there, and we know EIGRP is fine and everything below it between R1 and R5. So this starts to look like a little bit of a redistribution issue, doesn't it, between two routing domains? Wow, how much we discover with just a couple of commands. It's amazing. Let me skip over to R5, the ABR, or rather the ASBR, really, of the area 04 OSPF. And over on R5, I'll go ahead and just do a show run here, and we'll look at the routing configurations. Okay, here's OSPF, and sure enough, nothing being redistributed into OSPF. And here is EIGRP, and sure enough, nothing being redistributed into EIGRP. So let's go ahead and do mutual redistribution here. By the way, if I do a show IP route, we can see we have OSPF routes from the domain in the routing table. All right, we're going to go ahead and do router OSPF1. We're going to redistribute EIGRP 100, and let's not forget that subnets keyword. Then router EIGRP 100, we're going to redistribute OSPF1. And we remember we have to use a metric. The metric is arbitrary here, so I'll just put in our quad 1s there. We'll end the configuration. We'll slide back over to the R1 device. We'll do our show IP route, and we got a nice big routing table developing here. Can we ping the particular loopback interface that we are interested in, though? No, we cannot. We are not picking up a route to the loopback that would be sourcing the correct time via NTP to us. By the way, it's great that we have this reachability testing that we can do, because NTP, as you know, takes forever to synchronize, a relatively long time to synchronize. So in other words, what I'm saying here is, even though we just solved something major with this trouble ticket, we can quickly verify that there are additional problems because we can't reach the loopback 0 interface of R9. Yeah, that's great. We know NTP isn't going to have a chance at working correctly until we can reach that particular interface. Well, now let me do some quick fire verification testing all the way at R9. So I'm going to go over, you know we like to do that. We go to the destination device now, and I do like show IP OSPF neighbor. I'm trying to be really quick now because the time is ticking, and I'm trying to determine, do we have neighborships? That'll verify layer 1, layer 2, and some of the layer 3 config. Yep, we're neighbored with R7 just fine. All right, let's slide over to the R7 device. Show IP OSPF neighbor. We are neighbored with R9 and R6. Okay, that looks great. Let me slide over to the R6 device. And we'll do our show IP OSPF neighbor. And we have a problem. Yeah, we have a problem. The virtual link. Look at that. There is a neighborship for R7. There is a neighborship for R2. But as we can see in the diagram, there is a virtual link in place here to connect the discontiguous area zeros. So let me just do this. Show run section OSPF. Let's see what's going on with the virtual link. Area 2, virtual link. Yes, it's referencing the correct R4 address. Message digest key 1, MD5 Cisco, and that indicates, as we are supposed to do MD5 authentication in area 0 using key 1. All right, so that looks good. Let me go over to the other endpoint, the R4 device. And we'll do our show run section OSPF. Gosh, I love that section command. Oh, and look at this. Nice try. Comparing the area virtual link configuration from R6 to R4, we quickly see someone made a mistake here. They've got the area 0 reference here when it, on the virtual link. Area 0 on the virtual link when it needs to be area 2. All right, well, let's fix this. So we say area 2, or first, let's get rid of that. No area 0 virtual. We got to be in the correct mode. Okay, no area 0 virtual link 192.1.6.6. It's interesting. Oh, and look at that. It's so easy to make a mistake. There we go. It's interesting that you can't just negate this whole string. You've got to negate just this portion to get rid of it. Let's confirm that. Do show run section OSPF. Okay, the virtual link statement is gone. Now let's put in the correct one. It's going to be area 2 virtual link 192.1.6.6 message digest key 1 MD5 Cisco. All right, if that worked, we should get an adjacency. Oh, console messaging is disabled, so I have to go show IP OSPF neighbor. Yep, and look at this. We now have the virtual link up. Cisco really tries to mess with you by disabling the console messaging. So you don't see right off the bat what you would expect to see when it comes to these adjacencies forming. All right, well, I slide over to R1 now, and I ping 192.1, what was the address? Let's take a look. Show run include NTP. 192.199 we should be able to reach. 192.1.9.9. Ah, look at that. And thanks to the repair of the virtual link issue, we can indeed reach the NTP server. And now you could do debug NTP all and note things in your tracker. Note the fact that you've got to come back and check on NTP. Yeah, you don't want to sit here and wait for NTP to sync because it could take as long as 5 or 10 minutes. You'll see eventually, with its intervals, you'll see console messages here. Make sure you're logging to the console. So you'll eventually see some debug output regarding NTP, and it will eventually sync. Show NTP associations details, another good command. And we can see we're not even close yet. Trust me, it's going to take 5 to 10 minutes. So you'll want to note that you have to come back and verify this in your tracker. And isn't that interesting? You're going to have to come back and verify. Now here's the deal, folks. Here's a great example of how you think you just got 3 points, okay? So you run off, you go do some other tickets, you come back to this one, and you do show NTP associations detail, and the clock is synced. Sure. And you go, great, I just got 3 points. Guess what? You got 0 points. This is how tricky the tickets can be. Do you notice that our area 0, according to the diagram, should be authenticated with key 1? Well, if you go over to R5 and you take a look at R5 and do show IP OSPF interface FA0/1, you see that there is no key configured and you're using the default key of 0 for the MD5 authentication. Oh my goodness. So we think we had solved the ticket, but in this tricky circumstance, we didn't. What we need to do is go under the appropriate interfaces here in this scenario, and we need to say IP OSPF message digest key 1 MD5 Cisco. And I'm going to copy that to the clipboard, and I'm going to go ahead and make sure that we have that on R4 as well, on the appropriate interface, of course. And I'm going to go over and make sure this exists on R6. Once again, under the appropriate interface. And finally, R7. Now you do a verification in one of those areas. Show IP OSPF interface, FA0/0 for instance here. We're going to see that we are indeed doing MD5 authentication with our key ID of 1. And now we truly have met the diagram's specifications for what needs to be happening in this particular ticket. By the way, we've spent enough time. Let's go back over and see what's going on R1. Let's do a show log and see if we've gotten anything in there related to NTP. And no, not yet. Nothing related to NTP. Like I said, it will take a really long time for us to go ahead and sync up. At this point, our ping, as I did a moment ago, our ping to the NTP time server is going to be adequate for us to go ahead and note on this ticket tracker what's happening and go ahead and move on to another ticket, cycling back here just to go ahead and verify that time is truly synchronized. Well, I sure hope you have enjoyed the solution to this remarkably realistic Cisco trouble ticket, and we sure hope you have enjoyed this entire exercise and learned just how many pitfalls can exist in one of these trouble tickets. And also, of course, very importantly, using that quick fire strategy to manage all these landmines and circumvent them very, very easily. Thanks again for joining us, everyone.